sorry I'm not going to show you the Playboy today. I decided very narrowly to take it out of the talk. And you can always go to my website afterwards and find it hidden somewhere. So thanks, Ben, for the introduction. Thanks for having me to be a part of this awesome event. I'm going to tell you about how making images of my work and showing it to other people has made me think about how to communicate science to broad audiences. And I don't think it's working, so I'm going to stand here. So the Cathedral of Milan, which was built in about 1500, has these beautiful stained glass windows. And it turns out that the different colors in the windows were created by heating materials containing gold to different temperatures. And the folks who built the cathedral perfected that process, but they didn't understand what was going on. And almost 500 years later, we are now able to make very small particles of different materials and understand that the size of the particles relates to their color. So in addition to teaching us what was going on and we couldn't see back in history, we can also use materials like this to make more advanced solar cells and also create new methods of imaging for curing and treating diseases such as cancer. And as technology and society have advanced hand in hand, we've always been curious to see smaller and smaller things. So just after the cathedral was built in about the 1600s, Robert Hooke made these fantastic drawings. This is of a pollen colony, and he could see things about 1 millimeter wide. And in the present day, we can create pictures of materials where we can see individual atoms. And in fact, this is a picture of one of the particles that was in one of the colored vials on the previous slide. So our ability over the past 400 years to improve the smallest thing we can see by maybe a factor of 10 to 100 million is essentially enabling the field of nanotechnology. And nanotechnology is in some ways the science of the invisible. And there's a lot of discussion about what nanotechnology could be, and some people think it might very well be the next industrial revolution. We're in the revolution of information and communication now, and over the next decades we might have a revolution in materials, what it means for the way we handle our bodies and how we handle energy and how we address some of the world's problems. And such prospects have led to a lot of interesting predictions. For example, studies say that nanotechnology might contribute $1 trillion or more to our economy in the next couple of decades. Also leads to things like Michael Crichton's book Prey, that say that we're going to have these swarms of nanobots come and take over and kill us all. And we also see things like the Tata Nano, and I'm sure there are a bunch of iPod Nanos in this room, but that's not really nano. But all of these are examples of how the perception, the prospects, the hype, and the reality of a new technology lead to different expressions of what it could mean for society. And I work on a particular type of nanomaterial called carbon nanotubes. And the graphic is a bit messed up, but here's a real model of one. If this were real, it would be 1 nanometer across, which is 1/50,000th the diameter of one of your hairs. And a unique aspect of nanotubes is the bonds are so strong that if this were a wire, it would be tens of times stronger and stiffer than steel, and would also conduct heat and electricity perhaps better than copper. And as a result of these interesting properties, there are then a lot of predictions about what we could do with materials like this if we could control their synthesis and make them very big. For example, there's speculation that we could build an elevator to space. Nanotubes are the only material that could facilitate that. I believe that may never happen, but they're so strong that we could suspend an entire fully loaded 747 by a cable only 1/4 of an inch in diameter. The surface properties of nanotubes also facilitate us, and this probably will happen, to make gloves that would let us climb walls like gecko lizards do. And there are further efforts on use of nanotubes for water purification, for improving the cooling capacity of computer chips, and these materials and others would have a lot of practical impact. So in the lab every day on North Campus we grow nanotubes, and what I mean by grow is we take a silicon wafer, basically a shiny plate, and we put a whole bunch of small particles of metal on this plate. And we put it in a furnace at a very high temperature, or we put it on a hot plate, such as the one down here at about 1500 degrees Fahrenheit, and when we fill the furnace with essentially natural gas, the nanotubes grow upward, kind of like plants, but they're growing by a chemical reaction. And here is a video, or should have been a video, sorry, of an individual nanotube growing under a microscope. And basically you would see it looks like a little tadpole that grows and winds, but it's not a tadpole, it's something that's only 5 nanometers across, or 1/10,000th the size of your hair. And we don't grow 1 nanotube, but we grow billions of them at a time. And here's a picture of a forest of nanotubes. This is about 1 centimeter across, the black area here, and you have 20 billion nanotubes growing in parallel. So it really is like a very, very tall forest. And although there are 20 billion nanotubes here in this map, there's so much empty space in there that it's about 99% air. So if we imagine we were inside an electron microscope or inside the forest would look something like this. So here are the individual nanotubes inside the forest. They look like vines or trees. And if this were a real scale image, again, the analogy of one of our hairs, the diameter of a human hair would be much larger than the diameter of this auditorium. So it really is a fantastically small scale. And if we imagine that the size of one of these is 1 foot across, and we were standing in this forest as they were growing, they would be growing past us at over 500 miles an hour, almost the speed of sound, and they would finish growing above 50,000 feet, 10 miles in the air above where a 747 flies when it crosses the ocean. And it's possible to control the growth, the formation of these structures in various interesting ways. For example, we can take an image we want to pattern in this material, and essentially by patterning a checkerboard, we can dictate where these structures grow. And when I was in graduate school and started working on these materials, how they look under the microscope became interesting to me, and how the results of expected or unexpected experiments look also became interesting to me. So often the most beautiful pictures come from experiments that don't go as planned, where in this case I decided to put a little weight on top of the nanotubes as they were growing, and I got these weird looking forms which I don't think I could have predicted how they would look in any way. And then I started getting interested in doing basic things like adding color to them, using Photoshop, and maybe creating a more interesting visual representation that I could show to people and use to describe what I was doing. I would be begged to ask, what the hell is that thing? I wouldn't expect it's necessarily a bunch of nanostructures. And other unexpected results of experiments give these kind of odd-looking forms. And I was looking at this in the microscope, and there's really not much you might learn from this scientifically, but for some reason I zoomed in on this little red circled area here, and I zoom in and I rotate the image, and it looks kind of like that. And then my mind made a weird connection to some advertising I had seen, and I thought of an ad. And Absolute Nano. And so I went on Google and I looked up the ad agency for the Absolute Vodka brand, and I found the director of the account at TBWA, and I wrote him a letter, a very nice letter where I included my images and said, hey, do you want to work together? And I got a letter back along with the original copy of what I submitted to him. And he said, as personally fascinating as I found your remarkable explorations of carbon nanotechnology, I have to return them to you. So I was not deterred, and some time went by. I finished grad school, I got a job, I came to Michigan, and one evening in the spring of 2008, I was at home, I was thinking about nano like I always do, and I was thinking about Obama because the election was going on, and the idea of Nano-Obama came to me. What would happen if we took the famous, Shepard Fairey's famous image of the perhaps president-to-be and made it out of nanotubes? So here are the nanobombs. And this stewed in my mind for a while, and I wasn't sure if I was going to suggest it to my students or what they would think of me when I decided we would make it, but we ended up going for it. And so we made these about 3 days, late on a Friday night before the election. And over the weekend, we took pictures of them with the electron microscope, and I made a website and just put these pictures up there. And in fact, said that each of these faces contained about 150 million carbon nanotubes. So these faces are actually something you could see barely with your naked eye. So they're really at the micro scale, but they're these nanotube forests that we saw before. And at that time, I sent the link to about 100 people, and I didn't really do anything else. And the day after the election, my phone in my office started ringing, and over the next few weeks, this became absolutely massively popular. I'm not showing you this to say, wow, I'm a little stressed, although it probably is the most famous thing I may ever do in my scientific career. Like we saw this morning, I had to figure out how to climb up. But it was covered by pretty much everyone. The top scientific literature, the British tabloids. I was interviewed by syndicated news services, Reuters and the Associated Press. It was covered on websites and blogs everywhere, translated into many languages. It was in major newspapers. I had friends calling me that it was on the newspapers they get when they go onto the subway in major cities. And it made me really think about what made this so popular. I sort of did it with the thought that it would be fun and maybe some people would like it. I really didn't think of the ramifications and how the world reacted to this perhaps very timely expression of science with current events now shapes how I think about promoting work that we do and trying to influence others to promote work in ways that attract broader audiences. So if we break down a whole bunch of the features in the media, there were a bunch of different reactions. So first, a lot of people said, well, wow, this is an example that nanotechnology is really here, because I can see it. It's not invisible to me anymore. Another one was, well, let's show Nanobomb and talk about science policy. There were a lot of articles that used the picture, and then we're talking about what Obama would do in his administration, because he had speculated that it would increase the budgets for federal agencies that fund research. There were also some people who said, is it a political statement? And that was honestly a very dicey thing for me to answer, especially when I had a reporter from Science Magazine on the phone asking me this question. I had to say that I probably wouldn't have done it if I had supported McCain, but I didn't mean it as a reason of endorsing Obama's election. And then, of course, there are people who said, wow, it's just a cool art project that's not really useful. And then the occasional, wow, what a waste of money. And I remember there was a comment on a blog that said, I hope this guy never gets another federally funded research grant because he's wasting his time. So if we look at the span of all these reactions to such a thing, we're wondering why did it create such a reaction? Why was it so interesting? So I'm taking this picture from a book I read recently by Randy Olson. It's called Don't Be Such a Scientist. And he was a tenured professor, a marine biologist, who quit his professorship to go to Hollywood to pursue his passion for filmmaking. And he talks about how communication in science and communication in Hollywood are very different. And he uses this picture of our friend Arnold to say that successful communications excite a whole bunch of different organs, meaning we have to excite the intellectual interest as well as the guttural interest. And he says that these four organs of mass communication perhaps get more appealing as you go down from the head. So in other terms, what I think that the Nanobomb did is it combined the cerebral with the guttural, or had some potential to arouse by creating a popular image and combining it with a new technology, and then has the potential to fulfill. So taking the science of nanotubes, or Arnold being a governor and being very serious about how to implement policies and improve the quality of life. And I felt that a demonstration like that would be a very effective way to tell a lot more people about what I was doing. And I would imagine that more people saw the work that we were doing here at Michigan because of this picture, and because they saw this picture, they read a little about what it was, and perhaps some people somewhere would be curious to find out more. So, in fact, the Nanobomb has made great gifts. I got a lot of emails after the election asking me directly if I could produce some for Christmas gifts and so on, and I really didn't do that. But fortunately, a few weeks ago, I was asked to give one to the president himself. I wasn't invited to go and give it to the president, but I sent it to Washington. It was presented to him at a meeting of his Council of Advisors on Science and Technology. And in fact, it was given to him at a meeting where they were talking about nanotechnology. So the idea of the object itself, to promote interest in nanotechnology, made it full circle to the president, where he was being aroused and fulfilled on this topic of great science. I would get a picture of him receiving it, but apparently the photographer left the room. They say he really liked it and might want to hang it in the West Wing, so I hope someday I get a picture. But more seriously, there's a lot of research that tells us that the ability to communicate understanding of new technology and new science to the public and to broad audiences is essential to realistic evaluation of the prospects and the fears and the uncertainties. With any new technology, there are good things and bad things. With nanotechnology, there's hope that it will solve energy crises, and there's concern that materials such as nanotubes might obey similar characteristics to asbestos and be damaging to us. And these are just some snapshots from a recent study taking the topic of nanotechnology and relating familiarity with that concept to fear of potential consequences of emerging and past issues such as mad cow disease, nuclear power, and genetically modified food. And our ability to perceive these potential impacts and consequences relates to a lot of things. Our cultural background, our religious background, the information we have access to, and so on. So, in conclusion, I just want to say that I encourage you to, no matter what you do, no matter what field you're in, think about how to tell others about your work and to arouse their interest and then to fulfill them with a bit of knowledge that might then, over the long run, lead us all to make impact and create a ripple like we're all talking about today. Thanks for listening.